Okay, so very welcome back once again to our tutorial series on the industry electronics. So in today's module, what we are going to do is have a look at this new electronic component which is called as trimmer or potentiometer. So essentially it is a variable resistor. It means we can vary the value of resistance, and we'll see how we will do that. But before that, let us see how this trimmer or potentiometer looks like. As you see on the screen, the body of it is color blue. At the bottom you have got three leads. There is something printed on the body of this potentiometer, and as I said, we are able to vary the value of this trimmer, which can be done by rotating this particular knob. Is in the golden color on the top. So it's the knob which you can move fully clockwise or anti-clockwise, and based on that you can vary the resistance value from the lowest possible to the highest possible. Okay, it has a maximum value. We'll see how much that value is, and we'll see how we can go from the lowest possible to the highest possible, and we'll see each of these leads, what they are, how they do. So there is some information printed here that is possibly linked to the manufacturing. Okay, and we'll see now how it goes. Okay, so we have to first see the back side of it. So let me show you the back side of it, and then top side and anything else. So here is a back side of this potentiometer. There is nothing we can learn from it because there is no further information. Now we'll have the top side look, but for that we will have to fix this device in component actually on this breadboard. We will fix it and then we'll see what else we can do. So to fix it, we have to put these leads in a breadboard in such a fashion that all three leads are distinct from each other. They do not make connections with each other. So we know how to use a breadboard accordingly. So here we go. What you can see, I have fixed this trimmer onto the breadboard, and this trimmer or potentiometer is fixed in such a way that I have used the three dots, 1, 2 and the third one, where somewhere here at the bottom the leads have been placed. And then, as you know, this column is short, so there is this wire I have put up. This column is short, so there is this wire I have put up, and then third column is also the short, so this column I have put up. So in fact I am actually accessing the leads of this trimmer through these three wires: central wire, and the two other one are the red one, central one is blue. Now here from the manufacturer, when I buy this component, there is something printed here, W103. So we'll understand the value of it. 103 means 1 you keep as it is, 0 you keep as it is, and 3 means you put 3 zeros in at the back of 10. 10000. It means 10,000 ohms. In short, in other words, 10 kilo ohm is the value of this resistance. If you have like 101, it means the total value of the resistance is 100. 1 indicates, the last digit indicates number of 0 you will put right over. So 101 means 100 ohms. 102 means 1 kilo ohm, and so on. So let us now see how we shall measure it, and to do that we have to use the DMN, that is digital multimeter. Okay, and we'll then move this knob fully clockwise and fully anti-clockwise, and then we'll see how the resistance value varies. But now, right now, when I bought it from the market, I haven't moved it, so I keep it like that only. Okay, and we'll see based on that how much value it shows. So let us use the digital multimeter. So here you can see on the screen, now we have got digital multimeter on board, and we have set the knob of this digital multimeter to a particular position. Let me take it closer here. It is 20 kilo ohm. Why I have set it to 20 kilo ohm? Because I know the maximum value of the trimmer is 10 kilo ohm by the printing on the body of it. So I know I have to select this one. I can choose the higher also, but I am choosing the closer range. I cannot have 2k and bottom range, so better is 20k. So once I choose the 20k, now I have two leads of the DMM. Let us do that and we'll see what value it shows on the screen. So what I'm gonna do is first thing, these two leads will see what values it shows. So first thing, let's say I have to connect between these two, the red one, and we'll understand. So red one shows me is showing continuous changes, so why not just hold it, because there is this body also. 9.55 kilo ohms, close to what we expect theoretically. Okay, so 9.55 kilo ohm. How about between this red and the blue, this red and the blue, and then we'll have another one. Let's say this is the red and this is the blue. We hold it firmly, so exactly half of it, 5 kilo ohm. Now what is left is this red. I can have with this red, and then I have this red, this blue and the red in fact, and it should be half k, 4.47. So approximately we'll say that it is at the midway actually. So the central terminal is the blue one, as you can see now. The central lead is blue one. So if I have the measurement between the two red leads, total value is 10k. If I choose blue one as a central one, which it is, and then measure between blue and this red, like these two, I have half of the value, 5k, and between these two I have another 5k. So it means I will now be able to understand, if I put this resistor in my circuit, this trimmer in my circuit in this current position, it is the way it is, and then based on these wires where they go in the rest of the circuit, I will know that between these two what is the resistance, between these two what is the resistance, and between these two what is the resistance. So basically the middle one is the common terminal. Now it's time we can just change the knob and we'll see how the value varies. So to change the knob I need a screwdriver, a very fine screwdriver, and accordingly I will be able to do that. So let us collect the screwdriver where it can be, where it is. So here I got the screwdriver, and now I am wanting to move the potentiometer to the fully clockwise or anti-clockwise. So I start with let us say fully clockwise first, and I have to hold it, and I do it, and I am doing it. So when it is in the circuit, actually it is continuously moving, so it depends like what is the value I am getting or what. Okay, I have to monitor it in real time, so it can be moved. Similarly, you can see that anti-clockwise it can also go. Okay, so let's say I have now move it to some random position, let's say like this, some change, and then I can go back again and make the same measurement to see what values I have. So first thing, between the two leads, for example, this is now 10 kilo ohm, this is now 3.83, just decreased, and now what is left, this one. So 10 minus 3 point would be the value of here, 6 point something should be, it should comes. You see now the value is like close to 5.77, and so you can now see that this two leads always give you 10k, but then with the middle one, blue one, which is a common pin, common lead, you have the change between this two and this two. Okay, let us move it further, and we'll see how it is going. Let us move it further. I did that, and now I want to see what values I see. Again, between these two I should have the same value, like let's say 9.55 or whatever, the 10k. Now between these two 5.87, let me clearly do it, 5.85. and what about these two, 3.73. so there is actually not much change, close to what we measured before, right? It looks like that. Let us try something else. Or is it like we have connected it properly or not? Let me see that. Yeah, I think it got connected very well, properly. It's not that we made a mistake. It is connected properly. Let us see this. So these values are, oh, let me check very well. 9.46, these two 6.12, 3.46. okay, 3.46. there is some problem with the potentiometer, it means, right? The trimmer is not good and we have to replace it. We'll see another trimmer. Okay, so once we know the positioning of all the leads, what we need to do is, we know that what is the resistance between the lead pair of the leads. So we can do one thing, this common pin we can connect to either left or right, and accordingly we'll see how the values change. For example, let me show that I connect these two leads somewhere here. One goes here and then one goes here. Okay, these two are together now, and now I want to measure the resistance between this and this, and then keep varying this port fully clockwise or anti-clockwise. I will see how much value it gives. So for example, let's say this guy is here and then it goes here, and the value I see is 6.23 kilo ohm. And now what I want to do is I change this clockwise. Let's say I moved it and I see the value. $6.35. I again want to just move it clockwise, maybe. Okay, and we'll see 6.47. How about we just move it clockwise? Let us say this is completely moving, actually, this clockwise and anti-clockwise. Little decrement, 5.93. How about more? 5.7. So the conclusion is this trimmer is bad. It shouldn't work like this. So this is how you can also, this is the lesson for troubleshooting, maybe. Yeah, we just learned today how we troubleshoot that this resistance or trimmer is not good, right? What if you, let's say, you make the connections like this, these two you short together, these two you short together, and then this 3.94, obviously whatever the remaining 10 minus 6 point something is this one, 3.94, right? Let us move this. It shouldn't work like this. It looks like completely bad. I'm moving it clockwise now. Can I move it? No. Can I? Okay. .86. Okay. 3.86, and if I move anti-clockwise, let's say fully anti-clockwise, let's say fully anti-clockwise, and then I make it 4.0, little increment. I want to go more. Let's say I did that more. What is the value I get now? 4.41, little more, but I have to do it a lot. It's not like this. It shouldn't work like this. This is completely not a good trimmer. Something is wrong here. Yeah, one more time, we'll see the value what we get. 4.68, a little. Oh, let it be very good reading. Why moving too much? 4.68. Yeah, it's not working. So this trimmer, conclusion is not good. You have to try another one. So today we in fact just didn't learn about the good trimmer or potentiometer, but we just know the procedure, and finally or eventually we found out the conclusion is the trimmer or this potentiometer or trimmer is not good component. Okay, so hope you found this module useful. If you did so, share it with others for a wider reach, and stay tuned for more engaging content like this. Till then, wish you a very happy learning.